Okay, LO5f describe the qualitatively the effect of position of center of gravity on the stability of the object. So we're talking about stability. What is stability? Basically, when you displace the object, stability refers to its ability to return to its original position when you displace the object. So when you push the object to its side, so let's say you push the object, will it come back to its original position or will it topple over, right? So really there's only two there's always only these two factors when we consider stability to do with moment. It's the width of the base area and the height of the CG, height of the center of gravity. Okay, why? In the previous question, right, we talked about how this guy, he would fall over. Why would he fall over? It's when his weight, center of gravity, which is when his weight reaches from x at his center of gravity, will result in a moment about the pivot that will cause him to topple over. Right, so we're talking about stability of the objects. It has a lot to do with that, and we're going to see, I just show you quickly this slide, right? So when will an object topple? Let's say these two objects with the height of the center of gravity is the same, so the first one is the original height. When will it topple? It will topple when you tilt it until the center of gravity is just beyond the pivot, right? And then when it's any further, it will result in a clockwise moment which will cause it to topple over, right? Before that, it will still come back. Same, but you see now when I increase the width of the base area, you notice that the center of gravity, with the increased width of the base area, the object has to be tilted with an angle so much higher in order for center of gravity to pass the pivoting point, right? So that's how increasing the width of the base area increases the stability. It makes it harder for the point where the center of gravity will result in a clockwise moment result in a moment about the pivot that will cause it to topple over. Lower center of gravity is the other factor. You can see these two objects, the same base area, the same width of the base area. One has a higher CG than the other. So if the higher CG, it is so much easier. It's just such a small angle, right, to tilt it before it will cross the pivot and result in a moment that will cause it to topple over. Whereas in this one, lower CG makes it more stable. So these are the two factors: increased width of base area and lower the CG. So back to this question, if they ask you which is more stable, I think very clearly B is more stable because it has a larger width of base area for reason 1. And actually for reason 2, it's height of CG. Even if you didn't know, it's always these two reasons. But why does this have a lower CG? Well, simply because you see in port A, there's more material on top. So the mass is a bit more top heavy. So because it's a bit more top heavy, the center of gravity will be shifted slightly above. Whereas this one, it's quite uniform, so the center of gravity is in the middle. So this has a lower CG. So reason 1, you have the answers now, okay? So it has a wider base area and a lower CG than compared to port A.